ACL, Access Control List. What is ACL? Very useful topic, very important topic, especially to security related. Okay, what is an ACL? Access Control List. So, access control list is an entry which actually allow or block any kind of traffic going from one interface to another interface. So when you configure routing on a router, everything is all the network advertise on the internet or in the local OSPF or EIGRP. Everybody can reach to each other. All kind of services are open. Think about like a building is built, new building has been built, but the problem is look like everybody is coming and going. There's no security guard is sitting outside to just to see who is coming, who's going. Okay, so these kind of things are there. So, but now we say no video to S1 to access this. So basically, if you see on this router, we can apply an access list to allow email a deny telnet. So we want to say, as of now, everything is open, but we have a policy that allow email and deny telnet. This is we are saying just only HR application access, no update, no FTP, no web. Basically, these are our company policy that based on the requirement, we should allow or block the certain type of traffic. So a TCP conversation like this, whenever you say, let's talk, okay, sure, let's talk, like TCP and then acknowledgement. I need to send me some data. Thanks, I received the request. And then you see TCP data, acknowledgement, fin. Fin is mean finish. I have finished and have no more data to send. Acknowledgement and TCP acknowledgement. Basically, this has happened during the TCP conversation, the initial chapter. Packet filtering, sometimes called the static packet filtering, access to the network by analyzing the incoming and outgoing packet, dropping based on the certain criteria. How we can allow or deny the traffic based on the source IP, destination IP, protocol carried by with the packet like IP, TCP, UDP. Router act as a packet filtering when it forward or deny packet according to the filtering rule. And ACL is a sequential list of the permit or deny statement known as access control entry. So it's like you can think about it. It's registered in front of your security guard. Whoever is coming in, whoever is going out, he will be checking the statement in the registered. Okay, is your name is there, and then he allows them to go outside or inside. Okay, so basically the ACL is a sequential list which permit and deny. Sequential mean that it has let's say it has the 10 entry. It will look for the first entry, second entry, third entry, fourth entry, fifth entry until there is a match. If there is no match, at the end there is a deny traffic automatically. Basically, you need to permit or deny any kind of traffic. If you do not permit it, it will be automatically denied once you apply the access list. So what is the packet filtering? Purpose of the ACL, frame header, IP address, for which network? Network B. Asking for port 80 services, yes, allow. So basically, you see this is what we are and deny, then deny. Basically, we can say for any network, let's say network B, we are saying that for port 80, we want to allow or deny. For network B, asking for port 80, yes, deny, and no, allow. So basically, you can build some kind of access list entries. So there are two types of access list. Standard access list, which is saying access list 10, and you see the standard access list only care about the source IP. It does not care about the destination IP. It just say where the packet is coming from. Source access list filter IP based on the source address only. Extended access list 103 permit TCP 192.168.30 any equal part. So basically in the extended access list you can see you are not just looking the source IP but destination IP and any port number as well. Destination. So you are saying any traffic for TCP coming from this network going anywhere for port 80 equal is will be permitted. Extended access is filtered based on the several attributes, including the following: source and destination IP, source and destination TCP UDP port, protocol type, and all those. So tell me which access list is more secure, standard or extended? Extended, good, good, because it actually filtering, it actually have more option than the standard access list. You can also have the number. So how you can define this is a standard, this is this is the extended access list. Based on the number from 1 to 99 or 1300 to 1999, we have a standard IP access list. From 199 to 2000, standard IP access list. Basically, if you define a number, that is called the it will define itself automatically just the standard or extended access list. You assign a name by providing. Also, you can create an access list just by name as well. Okay, name cannot contain space or punctuation. So how the ACL works? So inbound ACL or outbound ACL. Inbound ACL. An inbound ACL packet filtering coming into a specific interface and before they are routed to the outbound network. So basically, if the traffic, so basically you have, before the traffic is coming from here, if you apply the access list can be applied inbound or outbound. So now the router is receiving the packet. There is an access list entry here. Just look like a card sitting here. There is a card sitting here. Okay, and it has a table. In the table, check okay who you are, where you want to go, and based on that, he permit or deny the traffic. The input ACL packet coming into specific interface. Coming. Okay, look at this. Coming into specific interface. Let's say F00 is the interface. Okay, interface, and before they are routed to the outbound network. So the traffic has not just entered to the router. While the outbound is an outbound ACL filter access being routed regardless of the inbound interface. Okay, the packet is already entered into the router. After being routed, the packet is routed that which interface you need to leave, and regardless of the inbound interface. So you don't know which interface is coming. You just apply that traffic and leave that network or not. The last statement of the ACL is implicit deny. So keep in mind at the end, if you do not put any entry, implements deny is there all the time. This statement is automatically inserted at the end of each ACL even though it is not physically present. The implicit deny block all traffic. Because in the implicit deny, an ACL does not have at least one permit statement. Okay, wildcard mask we also use into the OSPF as well. So keep in mind the wildcard mask is the reverse of subnet mask. Wildcard mask means when there is a zero, wildcard mask either can be 0 or 1. Match the corresponding bit to value in the address. Ignore the corresponding bit in the address. So basically, if the IP address, this is the it's the much easier way is just this simple. Okay, calculating the wildcard mask can be challenging. One shortcut method is this: the substitute. So take 255.255.255 and minus this, minus your subnet mask. So whatever the subnet mask you want to define, you have the in the. So you can take the 255.255 and wherever the 11, this is 0 and this is 255. Okay. If there is a subnet mask is 240, then you see is 15 is the 15 is the one. Okay, 255. Similarly 0. And if you have 252 here, you see 355. So this is how you're defining the wildcard mask. So in the access list, you need to say permit 00 any. 00 mean any. Okay. This is the same. Use ACL in the firewall router position between your network and external network such as internet. Use ACL in the router position between part of your network. 3 IP. An ACL per protocol. Okay, what do you mean by 3 IP? It per protocol to traffic flow on an interface. ACL must be defined. Each protocol enable on the interface. So basically, first of all, you define the ACL based on the protocol, and then you enable it on the interface. one ACL per direction. Okay, 3P. So one protocol per direction, per protocol per direction, like either inbound or outbound, and per interface. So you see, that's why you call it 3P, per protocol, per direction, per interface. Each ACL can be only applied to per protocol. Like if it's TCP, UDP, you just create one ACL entry, and then per direction and the per interface. You can apply on the interface. Okay. For example, here you can see one example. Access list 1, permit 192.168 this, and deny any. Okay, basically then also you need to apply this with the command. So you define the access list and then you apply the access group. The access group command, if you apply the create an access list, but if you do not apply this, this will not work. You need to create an entry and apply this on the interface. You can put some kind of comments as well between them, that why you are creating this access list. And if you want to edit the access list, I will show you as well. How you can verify show IP interface. You will see there is outgoing access applied. Show IP interface, not show IP interface. Show access list. And you will see if it's matching, it will be. Let me show you how we can configure the access list. So on this London router, from this machine, traffic is entering to the router. Okay, so you can apply this access list here. So first of all, you can let's see how we can access this. Access list question mark. You see the standard access list start from 199. If I just say, let's say 20, deny, permitted deny. So I'm saying deny 192.168.10.0. What will be the subnet mask, the wildcard mask? Now, I created an access list 20 here. Right now, the communication is already going on. Okay, this communication is going on. But now what I did is I said deny IP, deny 192.168.10. And then we need to go into the interface IP access group command 20 in. Now you see what happened. See this destination host is unreachable. Because on this interface, on this router, say configure show IP access list 20. It has 16 matches. We are denying this traffic. So we are saying anybody coming from here, okay, it will be denied. Okay. Now we are simply denying that traffic. You can see destination. If you want to go into the interface and say no IP access group command, so you create an access list with the IP access group access list, but apply this with the access group command. Now you see it's working. I remove the access list from the interface and it starts working right now. Okay. If I apply this again, we'll see the communication will stop at that. So when the traffic is entering, the router check out the traffic is coming from 192.168.10 network, it will deny that. Now you see it's gone. Okay. can see I have just HTTP from here 172.168.75.10, and you can see I can log in. Okay, this machine. Now let's say I am going to create a extended access list. Okay, and I want to allow the ICMP but deny the HTTP. Basically, how we can do that? Access list 100. Okay, first of all, deny TCP source IP wildcard mask. Okay, equal to port 80. So what we are saying, that access is denied TCP 192.168 if the traffic is receiving from here and it's going to anywhere. This is the source IP, this is the destination, like any, equal to 80. We are saying if the traffic is coming from here and it's going to this server for port 80, it should be denied. Okay, but we also, when we do a deny, we need to apply the any as well. Permit. Okay. Basically, what we are saying, TCP 192.168 equal to 80 is denied. So you see the ping is working, but now we need to try to 172.68.75. See request timeout. 172.168.75.1. Okay. So you see it has the 1016 denying this traffic, but apply this. The other traffic is allowed, but the 420, 480 is denied. Okay, that's how you can verify that your communication is. Which one is working? If I remove this access list, right now on an interface, sorry, then now you see. But if I apply this, it's not working. Now see it's working. Okay, so show access list now. Look, It's not working. So access list 211 matches. Okay, if you want to modify an access list, the existing access list, how you can do it? IP access list. You need to type the IP access list extended, then the number 100, enter. So then you say permit. I just modify this access, right? Okay. But can you see the problem here? Anybody? Anybody see the problem? The first of all, we're denying the traffic. Then we're saying permit IP any, and we say permit UDP host equal to domain. Okay. So tell me what happened now.